Hi, everyone. Welcome back to our podcast. This is episode 3, and I am Andrea. As always, I've got my amazing co host, Eduardo, with me. Hi, Eduardo. How are you?
Hello, Andrea. Good morning. Well, good morning, good afternoon for you. I don't know. I always make the same mistakes. I think you're here. It's just too early for me.
Yeah, I just had lunch, and you're going to have breakfast. So,
Yeah. You just had lunch? That's late lunch.
well, it's 2 p.m. Yeah.
Yeah, I guess so. So, all right. I don't know why that was later. Anyway, what are we gonna talk about today?
Well,
I'll my
today
notes here.
we're diving into something super important in the data world, which is data engineering. So more and more companies become data driven. So the role of data engineering is more of a big deal. So Eduardo, you're the expert. Can you kick things off by explaining what data engineering is and why it is so important?
I mean, you take a look at we took a dive here, like on the last episode about database, and on the previous episode on AI, and the first episode on AI, really, it's kind of like, if we think about it, AI cannot happen without good data. Even though Gen AI is helping us move things forward and is a lot, there is a lot more things that you can do with it now, and it doesn't require the same level of data quality that you need to have before Gen AI for machine learning. There is still a fundamental aspect of good quality data that needs to happen in order to be able to do Gen AI efficiently. And so it's important for all of us to be able to understand what is it that you can do with data, how can you leverage the data, and be able to create pipelines into it. Why is this important? Every organization generates data. Every single organization generates data. There is a business, there is activity that is happening, and there is data being generated. And we are generating insane amount of data, more data than we have ever generated before. And that data has knowledge. And it's very hard for us to be able to do all the things all the analytics that we need to do in a database. The database is already serving the main application, is already serving, it's already processing activity from the users, the main product that we have. On top of that, we're going to try to throw it analytics, and that's where things start breaking. Things are not scaling, things don't get where it needs to be, and so that it needs to be another set of tools or pipelines that will allow us to get knowledge out of these data. And that's where data engineering comes through. What is the tools and the techniques that you need to do in order to be able to extract knowledge out of this data? The last time we talked about this other aspect of databases, which is data lakes and data warehouses. And we explained a little bit of the difference between of these two. Now, with data engineering is the process of how you do all of this, how you do the analytic side of the data. And you have done that. You have started doing that. You were able to start working through some of these pipelines to be able to get insights out of the data. What were some of the aspects of the scripts that you run? Were they live? I just want you to put a little bit of a frame as how you started building these pipelines. Do you remember them?
It's a long
Okay,
time ago.
folks. Thank you so much. That's a wrap. I was basing my entire episode based on Andrea being able to give us insight. Come on, I can't believe I have better memory than you.
I just had 2 kids and,
Oh,
mom's
okay, I
brain.
see. That's the mom's brain. Yeah. My wife has the same thing. Although I think it's more of a selective brain than a mom's brain. So, I mean, one of the aspects and where you started was not live analysis. It was these reports that will be run every week. And
Yeah,
so
like reports
the
from the data center to know how many calls and
exactly,
how long they were waiting and things like that.
exactly right. So I think One of the reports was every week, and another report was every day. And so, for a lot of you, you're already starting doing something. And in our case, when we started some of this data engineering, it was just a script, a Python script that was running on a Windows machine that was just on a schedule. It was very awesome. So it was just a Windows machine that was on a schedule. So you may start with that journey. You may start in the journey where, you know what, it's just something simple. You start playing with it, and now you just need to schedule it. And some of you may have Windows, some of you may have Mac, and you just schedule it on the tools that are available there. And it does something. Others, you may start in a database where you create a store procedure and you have it and it gets triggered based on an external event. That's a little bit more on the advanced side of things. It is still using the relational database, but you have code in SQL that is running in the database in order to modify, make changes to the data and get it to another place. So the journey, it starts with simple things that we do on a day-to-day. It was ad hoc analysis at the beginning where we were trying to get average handle time, number of calls and things like this from the contact center. And how can we automate that? How can we help us on our day-to-day, right? And so I think that's where a lot of us starts. It's just playing that ad hoc and automating it. And that's fine. As long as it works, start somewhere and start in that place. Python is becoming a really popular programming language in a lot of different aspects. Data is a big one where Python is just dominant around what you can do with it. So those are the things that are important. Most of us are already started doing it. And if you didn't catch everything I'm saying about why it's important for organization, is because you get a lot of insights. You can make a lot of decisions out of the analysis that you do on data, and it will give you a path forward into your organization, into your department, into things that you can do to improve into the business. So that is, in summary, what is important around data engineering. There is a whole aspect around it. There is a whole set of tools around it to help you get there.
Okay, so do you want to dive deeper into what really is and what their main parts of
Today,
data
let's just keep it
engineering
simple.
pipeline is?
Let's keep it short. That was a good 5 minute podcast. Thank you. No, I'm just kidding. Don't go anywhere. The 2 people that are watching this, thank you. Keep watching. It gets better.
So seriously, what are the main parts of the data
You have
engineering
like
pipeline?
if you remember when you start at the beginning with a very simple script, you have your database. In a lot of cases, it's a relational database. That's where your main application is saving data. So you start there because that's where the data is. And then you have a script, whether it's that SQL script inside the database, or you have a Python script that is outside, or a completely different language script that you have. You have a script that is extracting that data and making a transformation. And then you have a destination, and this destination can be it can be the same database, which normally is not a good idea just because the database already has a lot of load from the main application. But it can be the same database. It can be another database, or it can be a data lake, or it can be a data warehouse. If you remember, a data lake is where you just get everything, put all the data that you want in it. The data warehouse is kind of like a database for analytics, where you have your storage in columns. So I'm not gonna deep dive. If you want to know more about it, watch our previous episode 2. But in this case, you have those 3 aspects. And what is happening in those 3 is that you may be iterating through this cycle multiple times until you get to the final version of your data. So you may be taking your raw data, making a transformation, putting it into data lake, then doing it again, taking it from your data lake, making a transformation, and putting it back into data lake, putting it into the warehouse. And you do that multiple times. Why would that happen? Well, maybe because you want to answer one question at the beginning, and then later on you need to answer another question, and it's like, I still need to answer question number 1, but now I need to answer question number 2. And so instead of having to make modifications and get the data and potentially break my data and the way that I'm transforming my data for question number 1, I'm going to evolve it and I'm going to make another transformation on top of it to make it into question number 2. The second reason why you also want to have multiple stages is for simplicity. Having too many steps into one script, or having too many transformation into one step, it creates complexity and it's difficult to troubleshoot. So there is something that, like in every system, it's something that's going to go wrong. It's not a matter of what if it goes wrong, it's a matter of when it goes wrong. So when you're transforming the data, it's a lot more difficult when you have 6, 7 transformations in one particular script, and all of a sudden the script is not working. And now you have to dig through where exactly it is not working. And your entire pipeline now is blocked because of that. Instead of breaking it into multiple steps, and now your pipeline, if it's broken, now it's only in one step, and then the other ones still can carry on, and you can just restart that step that it broke. And so it's a lot better for simplicity's sake to be able to do that. So those are the aspects from a process perspective. You have the observability, and that is very key. That's very important in every system, to be able to observe how the transformations are happening. And with data, when you are breaking it up into multiple steps, then you can get insight. You can export metrics into, hey, these steps, how many records did I process, how many records were successful, and how many records were not successful. And so being able to do that. So those are the main aspects. You have your source data, database, most probably a relational database, a script that is going to make transformation, enter a destination. And then the fourth part is just observability.
Okay, Eduardo. So you were talking about processing of data, right?
Correct.
Can you explain a little bit more of like the other stages of the pipeline, please?
So, I mean, so these are the main portions like you will consider, right? That's where you start when you start processing data. That's what happens. Now, within this processing, you have a few stages. Okay, you have the ingestion stage where you are kind of like going from that raw data, whether that is your like database or maybe an API. Most likely it's going to be the database, but it can be an API or it can be an external service. And then you're going to import that data. You're going to start doing something with the data. And then you're going to store it. Once you store it, you may have done initial transformation. You store it. And then what is going to happen next is that you're going to do transformation of data. Then you're going to output that data. And you're going to put it out. You have to orchestrate this dance of the stages of the data and where you're making manipulations. The other thing that is going to happen is that at some point you're going to be like, okay, I'm getting the data from this database, but now my team wants to add data from another place, an API or somewhere else to enrich the data, to make it better. And now I have to pull it from two sources, combine them, and have an output. So you need to orchestrate this dance of when this happens, when these different stages happen, all these multiple steps of data transformations happen. And you need to be able to orchestrate that in order to be able to get to a place where you get the answer that you're looking for. In this processing of the data, what are some of the techniques that you can start utilizing? You can start, you cannot just go ahead and like, oh, I'm going to start making the transformations. I was talking about it before, where you may be tempted to go and say, okay, I need to make 7 transformations, or I need to get it into this format in order to answer this question. And it's very easy to think of like, I'm just going to do all the transformations as soon as I'm just reading the data from the database and outputting it. Now, when you are talking about it, when you are starting to design this, you may go ahead and start doing transformations right away. The problem is that when something goes wrong, then you have to reprocess everything. And you're getting a hit into that raw system, that system that has the raw data. And most likely that is serving some type of production. So what you want to do is copy the data into another database or into another data storage. When you copy that data storage, then you're removing the dependency from the production environment, and you're just copying it. So the likelihood that something is going to go wrong with a copy, it's very, very minimal. And so you are improving your odds of being able to process this data efficiently into the future. Now, once you have it in a second storage, like it can be a copy of the database, it can be block storage, for example, S3 or Google Cloud Storage. You have it there, then you can start making a transformation. If something happens in your pipeline now, you can read again and you're not affecting production. You are completely separate from production and you can start making different changes to it. So it's very important for you to be able to do that in order to keep resiliency of the system. Kind of like that is the data ingestion portion of it, and being able to capture that raw data and move it into a place where you have you can start a data pipeline without the dependency of the production environment. So that is kind of like the ingestion part of it. Then you are orchestrating all the different steps that you're going to do to the transformation, all this script of data transformation to get into the place that you want to. Maybe it branches out into multiple different steps as you keep growing, and then it's gonna get to the place that you want to, and then finally you're putting into the final place where whether it's a data lake or whether it's a data warehouse or whether it's another database. So that will be the data being put into a different place. So
it's
that's kind of like
ingestion,
the
processing, storage, and orchestration.
Yeah. And the orchestration of all these steps, right?
Okay. And what are some tools that you use for that? Or
sorry, let me try to think about a joke and nothing came out. So I mean, what I'm talking about is like what I'm talking about is very complicated, right? Now when you start Andrea, the tools that we utilized to begin with, it was our MySQL database, and then we used Python, and then we just schedule it. And I can't remember what's the output, what we were saving the output. Maybe it was just generating that report and sending it over, or we were saving it into the database again. Now, this was a very small operation. We were talking about 20 agents. The database was probably around maybe 30, 40 gigabytes of data, which is very small. And so when you have this small data, you can start with very simple tools. In this case, it was just a Python script running on a Windows machine with the schedule to be every day or every week. When you start getting, one of the problems we start getting is that there were some more and more scripts and things started to fail a little bit more. So we needed to increase our reliability. And that's when we moved into a Linux system. It was still Python scripts. But then we start playing with, instead of saving the data back into the same database, saving the data into a replica database. And so then we have a movement from our primary database into a replica database. So we can start doing this. Now, this is on-prem, so block storage was a little bit more difficult to get from. And creating a data lake on-prem, it's a bigger task than doing it on the cloud. On the cloud, it's a lot simpler. And so when you are on-prem, most likely as you're growing, you're moving data from one database to another. And that's totally fine. When you're on the cloud, you can take advantage of a lot of different tools on the storage side and be able to give you that freedom to just store anything, a data lake based on S3 in AWS or a data lake based on Google Cloud Storage in GCP. Those are great options. Now, we've been talking about these scripts and how they do it. It is a lot easier to do this pipeline, this data pipeline and this data engineering on a batch system where you do not have to have live data, the live transformations, and be able to get the transformed data within seconds of the data being written in order to answer a question. doing batch where you do it every day, you do it every hour, you do it every week, that's a lot easier to be done. You have a lot of freedom to be able to create scripts that are complex, that create a lot of different things, and be able to have that time to be able to make the transformations. And so you can do that. There are different tools that help you in AWS. Lambda is a great tool to just have a script that is going to run, nothing complicated. It's just a script that is going to run every X amount of time that is going to make the transformation. You do have step functions that help you orchestrate to go from one step, go to the next one, go to the next one. It's kind of like this beautiful orchestrator where you set different scripts together, different Lambda functions, and you give them a flow of which one should be happening first and which should happen in second. But then in the other end, when you are doing live transformations, when you do need to do live analytics, that's when things get a lot more complicated because you need to process the data as fast as possible. And so what it's going to end up happening is that you want to have a data pipeline that is based on a queue system, where as soon as the data enters the database or it's written in raw form, it also enters a queue system where these lambdas can be listening to, and they can be processing things as fast as possible. And so it can enter a queue system. Those queue systems can be Apache Kafka, which is open source, and you can have it on-prem or you can have it on the cloud. And this Kafka is simply a way of like, I'm putting a message, I'm putting a piece of data into a queue, and Kafka allows me to control that order of what is arriving and what's getting processed. And so then you have scripts that can subscribe to Kafka to say, hey, I want to read this, and it reads and starts processing things. And so it does it very fast. And so it can handle very large amounts of inputs or very much of data being written into the queue. And then it's a matter of how many scripts you have reading that data so you can process that as fast as possible. Kafka is open source. You have other ones like AWS Kinesis in AWS. In Amazon, you also have PubSub that you can, although it's going away, and they are replacing it with Kafka in GCP. So, but you can definitely the solutions that are more managed where you don't have to deploy things yourself and manage infrastructure, rather just the logic of the data processing. But I hope I was able to explain a little bit why these systems are a little bit different when you are processing live data, that you need the speed and the ability to ingest large amounts of data fast in a very short period of time. The batch system where you have more freedom to be able to orchestrate different things.
Yes, sounds good. Okay, so do you want to talk a little bit more about skill building? So for
Yeah. Oh,
those who
sorry.
are,
The one thing that one thing
yes,
that I haven't talked about, but it's important, is on the storage side. So these are the tools to be able to do processing. But now on the storage side, and this is, I mean, as I was mentioning before, building a data lake on the cloud is a lot easier than doing it on-prem. But one of the things is your storage. What is the data how the format that you are storing the data? And that is very important to be able to process data efficiently. So if you remember, Andrea, when we were doing a lot of these transformations a long time ago, we were doing in CSV files. It was just converting CSV files, and that's because it gave us kind of like a similar format like in a spreadsheet, where you have your columns, everything is divided into by commas, and when you read it in Excel, it's like you can read it really nicely formatted. Now, the challenge with CSV files is that there is a lot of wasted information, like a wasted space in there. And that is because, for example, we were dealing with average handle times, we were dealing with numbers a lot. And so if you have repeated numbers, like somebody took 10 calls and somebody else took 10 calls, CSV file will have that information repeated. 10 calls and 10 calls. It's not going to try to optimize anything. It's just the data that you have, like the entire set of data that you have, it's going to be saved. With other formats of data storage, and I'm talking about in data lake, we are talking about Parquet, we are talking about Hive, sorry, not Hive. We're talking about Iceberg, we're talking about Delta Lake. These type of formats try to take advantage of being able to optimize the storage. So, for example, if you have repeated values, those values are not completely repeated. They are just reference. And so you are saving storage space in this. And the way that the data is written on the system is also optimized for being able to read it and be able to read it multiple times. In the data lake, I talk about icebergs and I talk about delta lakes. There is a couple of others, and I think this is worth diving into in a future episode. Delta lake, particularly lake houses, data lakes. How do you optimize these data lakes? Because there is a lot of things going on when you're putting a lot of data into a data lake, into one space. Stay tuned. There is going to be an episode coming up on data lakes, how to manage them, how to work with them, because it's very important to know how to optimize them to reduce costs, to improve efficiency, and be able to get there. But I just wanted to mention that there is an important aspect of your data storage format that needs to be taken into consideration in here. Now, skill building. You were talking about the skill building, and I think it's I think you can start with the storage right now is becoming cheaper, to be honest. So S3 is very cheap. You can have gigabytes of data there and just pay like a few cents to be able to do this. Now, you can also leverage a lot of the free credits. So, for example, AWS, Amazon has the same thing where you have free tiers and free money to be able to experiment with this. There are additional what can I say? Sorry, my train of thought went through. Sorry, Snowflake and Databricks also offer a lot of skills and a lot of tutorials to be able to get there. And Snowflake and Databricks are very important tools right now, or products that allow you to do data engineering and data transformations. And so I will consider taking a look into that. The thing is, start doing. You can even start in your own computer with a Python script and what is it called? And just a database that you can install or an API and start making transformations. Python is going to be key. Learn Python, learn how to do that, learn SQL. So these are the two programming languages that I would recommend as part of the data engineering toolbox is SQL. How do you create effective SQL queries? And then on the Python side of things, how do you program and code all of these? So that's kind of like the starting points. Once you get into more advanced topics, then you can start looking at Kafka as kind of like your key orchestration. You're going to start taking a look at Airflow. I didn't touch about Airflow and these tools of being able to help you schedule these scripts into a series of steps. So I kind of like touch base on AWS step functions that help you orchestrate. Okay, script number 1 is going to do this, script number 2 is going to do that, could be the output of script number 1. Airflow is another open source tool that you can even install on your local computer and be able to start playing with orchestration. How do you go multiple steps into your scripts and orchestrate those ones? And so once you get into that space, now there is going to be a time, or maybe you're already there, where you're like, you know what, I'm done dealing with megabytes of data. I need to be dealing with gigabytes of data or terabytes of data, so very large scale data. And that's where you get into a space with tools like Spark. And Spark is, so let me step back a moment. If you start in Python, you're going to start using tools like lists and arrays. More efficient ways of manipulating data at this stage is going to be NumPy and Pandas. And Pandas will allow you to make manipulations of data very efficiently. There is a lot of optimization behind this library in order to be able to process data in a very efficient way. Once you get into a larger space of data, then you're looking at Spark. And a Spark, imagine that is pandas, and imagine that is one Python script with distributed compute. So instead of running into one laptop or into one server, now you're using 5, 6, 10, 20, 50 different servers to be able to process your data. And so Spark, what it's going to do is say, you want to do the average of this metric. It's going to split and it's going to say, now I'm going to get 10 computers to take a piece of the data to the calculations, and then they're going to send me back the data, and I'm going to aggregate all that data to give you the results. So Spark gets into the power of distributed analytics, and that's when things are getting really fun. You can do Spark on-prem. It's not fun, to be honest. I have done it. It's not fun. So in AWS and in GCP, you have managed services. AWS is Amazon Glue, very powerful. Play with it. There is a lot of get started tutorials, and I'll add those links into our YouTube channel and to the podcast where you can get started with that. And GCP, there is a tool from the top of my notes. I don't have it, but there is also a tool for that. So keeping that, and you don't have to be spending a lot of money on that. The only thing I will say, like start with your laptop. You can install Airflow, you can install Python, and start playing with that. Fantastic way of starting with data engineering and
That's
start playing with
awesome.
things.
Yeah, so that's a great way to get your feet wet and start building those skills. Great.
So on next episode, we're going to talk about how Andrea installed Airflow and start playing with it.
Yes. A live demo. Okay, so moving on to career insights. So Eduardo, how's your journey been learning and evolving in the field of data engineering? Because you didn't start as a data engineer, so.
No, I did not start. I was customer service for a long time, and then I was project management. It's interesting when you are in a position where the organization at the time was focusing on sales, trying to make a lot of sales. So all the reporting and all the analytics were focused on that side. And in the customer service side, we were not having any traction to be able to do these analytics. And the business was still asking us questions, but we didn't have the bandwidth with the BI team to be able to do this, to the reporting team. So if you remember, Andrea, our team was handling the technology. We were responsible for configuring the system. And so we knew where the data was. We knew where the data was being saved. And so what we ended up doing is start building these dashboards and these reports ourselves. There were a lot of things. There were a lot of times that things went wrong. Like tools that we started using that seemed to be good, and then all of a sudden, like, you know what, this is very difficult to work with. It's not getting us where we want to. And we are 3-6 months into the project, and we need to back out and completely change things. There were a lot of great lessons that we got from that. There were a lot of great lessons that I got from that helped me continue my evolution into data. If you remember my previous episode, I also talk about how I created things without databases. It was just files. And I think that was also my first time touching analytics and be able to do reporting. What I will say is, like, start playing with data, start manipulating data. All of us touch data at some point in our daily jobs, whether that is how efficient I am at the job that I have, how many tests that I'm processing, like trying to just get insight into the things that we do day to day. And these are very small data points. I'll say, you know what, if you can start with that, that's a great aspect to be able to get you familiar with the tools and how to get that. And for me, that was a lot of what I was doing at the beginning. How do I solve these problems that the business is having? I was playing a lot on my own time, or like putting some spare time that I have during the work hours, where it's like, you know what, I want to do this better. I'm going to read about data engineering. I'm going to read about how come databases and just play around with it. At that moment, nothing there. I wasn't trying to solve a particular problem. I was just trying to play with it. I was trying to make something interesting. And at that particular moment when I was learning, maybe there was no particular use case that I had. But soon after, a few weeks later or a month later, there will be a business problem that I'm like, I can utilize that thing that I learned about a month ago, and then I can put it into practice. And then you'll have those skills under your belt. And it doesn't matter which part of the organization you're working with. If you're working on sales, it's rather important for you to be able to understand how your sales are doing and how you can improve that. In operations, every decision is made based on metrics. In security, you can take a look at how many threats you're receiving, all different aspects of the system. In the engineering side of things, the same thing. The amount of times that in DevOps I had to take a look at metrics to be able to understand where my systems were healthy or not. So start taking a look at that, start doing some analysis. The best thing to do is just start writing Python. What you will write today, if you're just starting this career, it's going to be very poor. It's going to be really bad compared to what you're going to be writing in 5-10 years. But it's an important lesson, understanding how you can improve that and how you can get started. If you already started and you're in your data engineering career path, you want to keep advancing, cloud is the way to go. There is a lot more things going on there. And if you haven't explored Snowflake, Databricks, or data lakes in AWS or GCP, that is the next step to do, is being able to explore those aspects. How do you work with these large amounts of data? How do you efficiently process live data? And right now, with Gen AI and AI coming away, this is important skills. How do you process large amount of data so that you are able to have the right piece of information, and then you will give it to AI to be able to do analysis on. And so that is very important to keep manage costs. So I will say data lakes, if you're already into it, data lakes, how do you create improvements into it? How do you find the right answer? And take a look into data lakes in AWS, data lakes in GCP, Snowflake, Databricks. If you already are into that space, how do you optimize it? How do you use Spark to do this? If you do all of that, then my challenge is, how do you use embeddings, find information in text data, unstructured data? So that is a challenge. How do you use embeddings to be able to do this? So that is my advice. And now we'll add resources in how to do this on our podcast in the description.
Cool, thank you. And I guess my advice to our listeners would be to stay curious, keep trying out new tools, techniques, and the more you practice, like with any skill, any sport, the better you get. So yeah, keep at it.
I mean, Andrea, that's why she doesn't remember anything. Because after she learned all those awesome skills around Python, she went and did translation and linguistics and other stuff.
No, I did linguistics before. So this
You
was
did
just
linguistics before this. A sad way.
Yeah. Anyway, it's not about me.
And so, we'll talk about it next in the next episode. I think we're running out of time on this one. We need to talk about what do you do in your job. What does a linguistic person do? But anyway, we'll talk about it in a future episode.
Yes. Okay, any last words, Eduardo? Before this episode
No, I think you said it. I think that was beautiful what you said. Stay curious.
Yeah. Okay, so that's a wrap for today. And then we will see each other next time. Please do subscribe to our channel, to our podcast. Thank you, Eduardo, for all your knowledge and insights.
I keep
building, learning. Yes.
Subscribe YouTube. You can help us grow from 2 to 3.
Apart from my husband, your wife, and my mom.
I mean, my wife's a writer. She's not into technology, so I told her, she's like, "That's exciting." I'm like, "Great, you can subscribe," and she's like, "Sure." She hasn't done that. I mean, she's not a technology person. She's a writer, so she's more into the arts and stuff like that. So,
Well, still.
but so for I'm gonna
Okay.
create for my kids too, so that they can subscribe. Anyway, thank you so much, everyone.
There you go.
This is fun. There's gonna be more topics to come through.
Okay. Bye, Eduardo. Thank you.